Hi everyone, today we're going to be talking as mean as a balance point. Mean as a balance point falls into the same category as mean, median, and mode, and it's going to be a way to visually represent the mean of a data set. So first let's talk about mean. Mean can be defined as the point on a number line where the data distribution is balanced. Think of it this way. If you have a seesaw, and you put a large marble on one side and you had a small marble on the other side, what's going to happen? The scale is going to tilt so that the large marble is on the bottom. But if we move the position of the larger marble towards the middle, we can actually get to a point where the two sides are balanced. And that's going to be what mean as a balance point is all about. In order for the data distribution to be balanced, it requires that the sum of the distances from the mean of all the points above the mean is equal to the sum of the distances from the mean of all the data points below the mean. And we're going to talk about what that looks like when we get to our examples. But all of this is a concept of mean as a balance point. So if we look at the example below, we have a line plot. And what a line plot does is it's kind of like a tally table, but instead of putting tally marks, we put X's. So let's say that this chart represented the number of siblings that people had. This shows that one person only has one sibling, 3 people had 2 siblings, 1 person had 5 siblings, and 1 person had 6 siblings. Now in this example, the mean of the data has already been shown. Now typically when you found mean in the past, you've added up all of the numbers and divided by the number of data points that you have. But I want to show you how we can use the distances to find the mean. So it says in our notes that the sum of the distances for all of the points above the mean is equal to the sum of the distances for all the data points below the mean. So let's talk about above the mean first. So that's everything up here. It looks like 5 is 1, 2 away from the mean. So that's a distance of 2. 6 is 1, 2, 3 away from the mean. So that's a distance of 3. So the sum of those distances is 5. Now let's look at below the mean. 2 is only 1 away from 3, so that's a distance of 1. What makes this different is that's only for one of these x's. So let's talk about the pink x. It is 1 away from 3, so we add a distance of 1. Same thing for that green x. It is 1 away from the mean, so we add a distance of 1. Now we need to find the distance from the 3 to this 1. 1, 2. So we add a distance of 2. If we find the sum of those distances, 1 plus 1 plus 1 plus 2 equals 5. Those two sums are equal to one another, so 3 is the mean or the balance point of this data set. Now finding mean as a balance point is actually kind of fun. It involves crossing out and moving points towards the middle until you can't anymore. The one thing you remember is that you're going to go left, right, almost like you're taking steps when you're walking. So here we want to find the mean as a balance point for the height of certain kids in inches. So we start on the outside. Our outsides are 54 and 43. I am going to start on the left, and I'm going to take one of these x's and I'm going to cross it out and move it towards the middle. Now I'm going to go over to the right hand side. I'm going to scratch out one of the x's from 54 and bring it into 53. So notice that I'm always moving in towards the middle. We're back to the left. I still have an x on 43. So I'm going to cross it out, put an X on 49. On the right, there's no more X's on 54, so we move to 53. I'm going to remove an X, move it towards the middle. I go back to the left. We're out of X's on 43, so we move to 49. We cross out an X, move it to the middle. Go back to the right. 53 is on the outside, so we cross out an X, move it to the middle. Go back to 49, cross out an X, move it to the middle. Go to 53, cross out an X, move it to the middle. And then we finish up with 49 and 53. And we end up with a situation where all of our data points are stacked on 51, so the balance point is 51. Let's try another example. Here we have the shoe sizes of 7th grade students. And just as before, we start on the outsides with 4 and 10. And I'm always going to be moving from the outside towards the middle. So starting with the left, I'm going to cross out from X, move to 5, cross out from 10, move to 4, or move to 9. Go back to the left, get rid of this from X, move it to 5. Moving back to the right, we cross out from 10, add it to 9. I'm going to finish this without any voiceover, and I'm going to speed it up. So just watch how I cross out and move towards the middle, always going left, right, left, right. All of our data points stack up on 7, so 7 is our mean or our balance point.